So let's fill in all those blanks there. We've got a few properties to go through. Okay, it says two chords are congruent if and only if the first statement that we're going to do is that their corresponding arcs are congruent. Okay, two chords are congruent if and only if their corresponding arcs are congruent. Now, you may see this notation somewhere along the line, an equal sign with a little squiggle over it. That means congruent. Okay, that means congruent. Essentially, you're saying that they're equal to one another, but it's just the technical notation there. Okay, so let's go to the diagram right there and kind of trace out what they're describing to us. Two chords are congruent, so the two chords that I see are A and B, or A to B. Okay, remember, a chord has its endpoints on the circle, and C to D. Okay, so what this is saying is it's saying that AB is equal to CD if the arc AB is equal to the arc CD. So the measure of arc AB is equal to the measure of arc CD. So these if and only if statements means that it can go both ways. If we know that AB is equal to CD, then we know that arc AB is equal to arc CD. Vice versa. If we know arc AB is equal to arc CD, then segment AB is equal to segment CD. That's what that's saying. Okay, now there's another way that we can know that chords are congruent. If they are equidistant, remember we used that term just a couple of weeks ago when we were doing centers of triangles, the same distance from the center. Of the circle. So again, AB is equal to CD. Two chords are congruent if they're equidistant from the center. So the distance from the center is EF and it's EG. Okay, if you look at the diagram, E is the center, so from E to F, that's the same length as from E to G. So same thing. If we know the two chords are congruent, then we know those distances are equal, or vice versa. If we know those distances are equal, then we know those chords are congruent. All right, the second thing that we can use with this, if a diameter or a radius is perpendicular to a chord, which we have in this diagram, okay, those radii form right angles with the chords, then it bisects the chord and its arc. If a diameter or radius is perpendicular to a chord, then it bisects the chord and its arc. So in those last blanks there, we're going to use the radius EH. I'm going to put a little line over it to represent a segment. Is perpendicular, that's the notation for perpendicular, to segment AB. EH, the radius, is perpendicular to AB, the chord. Then AF is equal to FB, and the measure of arc. Okay, where was I? Measure of the arc. the measure of AH is equal to the measure of HB. Okay, so if it's perpendicular, which it is, that chord is cut in half. So from A to F, from F to B, same distance, that arc is cut in half. So from A to H, H to B, same distance. Okay, so we're going to do a few problems just with the first bullet point right now. We'll come back to the second bullet point later. All right, let's look at example 1. Find X. So let's look at what's given to us in the diagram. We are told that these two chords are equal, because remember that tick mark means that they have the same length. So our property says if the chords are equal, then their arcs are equal. So from R to S, from T to S, those are equal. So 115 is equal to 7x plus 24. And we solve for x. So we subtract 24 from both sides. 91 is equal to 7x. Divide both sides by 7. 13 is equal to x. That's what they're asking us for. Find x. So we're finished. Okay. Number 2 flips that around. Number 2, they show us that these arcs are congruent and their chords are marked. So the arcs are congruent, then the chords are congruent. So 18x minus 2 is equal to 52. Add 2 to both sides. 18x is equal to 54. Divide by 18. X is equal to 3. And that's what we were looking for. So x is equal to 3. You can, of course, check that. Plug it back in. 18 times 3 minus 2. We're looking for that to be 52. And it is. Okay. Let's look at number 3. Find xy. Find xy. So this is what we are looking for, that segment length. So once we find x, we're going to have to do a little bit more work past that. So the arcs are marked as congruent. So those chords are equal. 9x minus 34 is equal to 4x plus 1. Solve for x. We got it on both sides. So subtract the 4x from both sides. 5x minus 34 is equal to 1. Add the 34 to both sides. 5x is equal to 35. Divide by 5. X is equal to 7. We're not finished. Find xy. Xy is equal to 4 times the x, which we just found was 7, plus 1. So 28 plus 1, xy is 29. It's a chord length, so it doesn't get a degree symbol or anything like that. It's just a number. Okay, number 4, find the measure of arc RS. So I encourage you, highlight it, darken it in, do something to remind yourself this is what I'm really looking for in the end. I want the measure of that arc. So the chords are marked congruent, so the arcs are equal. 11x minus 72 is equal to 5x plus 6. Subtract the 5x from both sides. 11x minus 5x is 6x. 6x minus 72 is equal to 6. Add the 72. 6x is equal to 78. Divide by 6. X is 13. We're not looking for x. We want RS. The expression for RS is 11 times Rx, which is 13, minus 72 which equals 71. This is an arc, so we put a degree symbol on it. That is a degree measure. Okay, number 5, same thing, just adding a little bit more thinking to it. Number 5 says just find x. Let's look at where x is in the equation. It is in the expression for the arc yz. But here's the problem. They do not give us an expression for yx. Now, based on the way that the picture is marked, they are equal to one another, but we don't have anything to set it equal to. But they are equal to one another, so they have the same expression. Now, it doesn't do us any good to set 6x minus 20 equal to 6x minus 20. Everything's going to cancel. So look at what else they give us. They give us that this arc right here is 76 degrees. So do we not have all the arcs marked around our circle? When we have that, then we add them all up and set them equal to what? 360. When we have all the arcs, we add them all together and set it equal to 360. So 6x minus 20 plus 6x minus 20 plus 76 equals 360. We have two variables on the same side, so we combine them. 6x plus 6x is 12x. Negative 20 minus 20 is negative 40 plus 76 is 36. And now we can subtract the 36, so we get 12x is equal to 324, and divide by 12, so x is equal to 27. And that is what they were asking us for. What is x equal to? Now, if you're like me, I want to make sure that I did it right, so I'm going to go back and I'm going to plug in 27 for x and plug it into all my pieces and make sure that they all add up to 360. And they did. Okay, number 6. 2 more examples and we'll be done for a second. Number 6, if MP, so MP is right here in the picture, is 5x minus 34, and PN is 2x minus 4, find MP. So what do we know about those two segments right there? The arcs are congruent, so the chords are congruent. If the arcs and the chords are congruent, then they are equidistant from the center. So MP, PN, same length. So they are equal to one another. 5x minus 34 is equal to 2x minus 4. Solve it. Subtract the 2x from both sides. 3x minus 34 is equal to negative 4. Add 34 to both sides. 3x is equal to 30. Divide by 3. X is equal to 10. They didn't want x. We want MP. We have an expression for MP. 5 times x minus 34. 50 minus 34 is 16. It's a length. It is not an arc. So we just leave it as 16. Okay, one more for the time being, and then we'll come back to the rest of these. Number 7, if DE is 11x plus 15, and FG is 32x minus 27, find DE. So So DE, they give us an expression for that. They give us an expression for FG. They have shown us that they are the same distance. That's what's marked. So if they're the same distance from the center, then those chords are equal to one another. So set them equal. Solve for x. Subtract 11x from both sides. 15 is equal to 21x. Add 27 to both sides. 42 is equal to 21x. Divide by 21. 2 is equal to x. We don't want x. We want DE. So we've got to plug it back into the expression for DE. 11 times 2 plus 15. 22 plus 15 is 37. It's a chord, so it's a length. It does not have a degree symbol. 37.